Hello students, today I am here to just start new topic for class 11. The name of topic is mechanics. Before starting the topic mechanics, I want to make clear one thing. What is mechanics? My dear students, you always find a body or object either in rest position or in moving position. Mechanics is that branch of physics in which we study, in which we deals with the body when the body is in motion. Mechanics is of three types. The first part of the mechanics is called statics, second part is called dynamics, and third part is called kinematics. Static is a branch of physics. It is sub branch of mechanics in which we deals with the study of body in rest. That means whenever a body is in rest and we are discussing that body, then the branch of physics is called statics, and this statics is the sub branch of mechanics. Number two is dynamics. Dynamics is also a sub branch of mechanics, but it deals with the study of body when the body is in motion. Remember that taking account cause of motion. That means why the motion take place. When this particular sentence come why the motion take place, then that branch of physics is called dynamics and it is sub branch of mechanics. And the third one is kinematics. It is just like dynamics, but the difference is what? Here it is not countable what is the cause of motion. Means dynamics and kinematics both are just same meaning, but difference is what? In dynamics, cause of motion is having its own account why the motion take place, but in kinematics it is not counted what's the cause of motion. So this is mechanics and these three are the sub branches of mechanics. Now I told you that either the body will be in rest or body will be in motion. Here we are discussing about the motion of body. So the question is, what is motion? My dear students, in your daily life you can observe the change of position of different types of bodies. Like when you wake up in the morning, you come out from your room, means your position changes. When you see the clock, wall clock, you can see the change of position of second hand or minute hand or hour hand. So many things like vehicle. You observe a vehicle in front of you. After certain time, that vehicle passes and reaches somewhere else. So this is the example of motion. In all these examples, what you are observing? You are observing that the body's position is changing continuously. Not only position, one more thing is changing, and that is time. So motion is defined as whenever any body changes its position with respect to time, then body is said to be in motion. Now the question is, what are the types of motion? Depending upon direction of motion, there exist three types of motion: one dimensional, two dimensional, three dimensional. Here the word dimensional means direction, or you can say axis. You can define all the types of motion in a coordinate system. Like this is x-axis, that is horizontal line. This is y-axis, that is vertical line. If any body is moving along any one axis, either x-axis or y-axis or z-axis, along any one axis, then motion is called one dimension. In two dimension, if body is moving along any two axis, means along any plane, this plane is xy. In the same way, if body is moving in this particular plane, that is yz. In this way, if body is moving in this particular plane, that is xz. Then the motion of body is called two-dimensional motion. Three-dimensional motion is body is moving along all the three axes. Then the motion is called three-dimension. The best example for one dimension is motion of car on a straight road. Two-dimensional, very common example for two-dimensional motion is circular motion, and secondly projectile motion. Both examples you will study in large way in other chapters. Three-dimensional motion, number of examples are present for three-dimensional motion, like rotation of earth, like motion of mosquito, like motion of kite in the sky. So many examples are present for the three-dimensional motion. So this is motion and types of motion. Now my dear students, if we want to observe motion of any body, then what we should do? First of all, to observe the motion of body, we should have a reference point. Now question is, what is reference point? Reference point is that point from where we are going to observe the motion of body. Suppose that any body is in motion. Yeah, you can take the example of a train. A train is moving from Gonda to Lucknow, but you are standing at the Barabanki. So you are observing the train at the Barabanki only. So your reference point is Barabanki. So now from that station, whatever the motion you will observe, that point is known as reference point. So here I am going to start another topic, that is frame of reference. So frame of reference is what definition is written here. Just try to understand. System of coordinate axes attached to an observer having a clock with him with respect to which observer can describe position, displacement, acceleration, speed, velocity, etc. Means what? The frame of reference is what? This is a combination of an observer, of a coordinate system. Okay. Now you are having a coordinate system. In that coordinate system, you are going to describe a motion. Now that described motion you are going to observe. So that point from where you are going to observe motion in that particular coordinate system is called frame of reference. Frame of reference is of two types: inertial frame of reference and non-inertial frame of reference. Inertial frame of reference is that frame of reference which obeys Newton's first law, and non-inertial frame of reference is that frame of reference which do not obey first law of Newton. Now, there are two types of physical quantities. The first one is called scalar and second one is called vector. Question is, what is scalar? What is it? There are so many physical quantities for which measurement we require magnitude, or we require magnitude as well as direction. So those physical quantities for which measurement we require only magnitude, like speed, like distance, like time, like mass, all etc. There are number of physical quantities. These are called scalar. And vector quantities are those quantities in which magnitude as well as direction both required. It's called vector. Example is force, example is momentum, etc. are the example of vector quantities. So scalar quantities, vector quantities, what is the need here? Because here we are going to discuss factors of motion, and those factors also depends, some factors depends upon direction, some does not depend. So you should understand before that what is scalar quantity and what is vector quantity. Okay. Now my next topic is elements of motion. Look here. Here are some elements of motion. The question is, what is elements of motion? Elements of motion means those physical quantities over which motion depends, or which counted the motion, like distance, displacement, speed, velocity, acceleration. So we will go one by one. Distance. Suppose that this is any point A and this is any point B, and you want to go from A to B. So there is one way is this, second way is this, and third way is this. There are three directions to move from A to B. A boy is going from first path, another boy is going from second path, another boy is going from third path. So distance is what? Length between the initial and final position covered by any body. For boy 1, this is the distance. For boy 2, this is the distance. For boy 3, this is the distance. Whatever the path followed by any body to move from initial position to the final position, the length of that path is known as distance. Because it is direction independent, due to that it is scalar. No fixed direction. From anywhere you can move. If you talk about displacement, now in all these three, this path 1 is the shortest way to go from initial point to final point. Means it specifies the direction. Due to that, displacement is vector quantity. So distance and displacement both is the path length. But remember that distance is the path length, does not depend upon direction. Displacement is the path length, depend upon direction means displacement is the shortest path length, you can say, from initial point to final point. Speed is distance per unit time. When distance divided by time, you will get speed. Velocity when displacement divided by time, you will get velocity. That is, speed is scalar, velocity is vector. Now question is, what is acceleration? Acceleration is change in velocity per unit time. The meaning of change in velocity: a body starts motion. During the starting point, its velocity, and during the motion when body comes at the final point, then its velocity, both are different. So the velocity by which motion is start, that is initial, and the velocity at which motion ends, that is final. So change in velocity means final velocity minus initial divided by time. This is called acceleration. Because acceleration is the ratio of velocity and time, due to that this is also vector. So these are the elements of motion. Now these 1, 2, 3, 4 are the types of speed: uniform speed, variable speed, average speed, instantaneous speed. So go one by one. If uniform speed consists from distance and time. So if any body covers equal distance in equal time, then speed will be constant. That constant speed is called uniform speed. Okay. Variable means which is not constant. So if distance traveled is equal distribution but time distribution is unequal, then the speed will become variable speed. Average speed during the motion, number of times unequal distances are there, unequal time is there. So whatever the total distance covered by body, in that total time, that ratio is called average speed. Instantaneous speed, the word instantaneous means at any instant, or in another way you can say at any moment. So the speed of body at any instant, at any moment during motion is called instantaneous speed, and it is given by the formula dx by dt. This d by dt is called differentiation, and x is here distance. Remember that, because it is speed, so x indicates position, that position refers to distance. So when distance differentiate with respect to time, then it will give instantaneous speed. Now types of velocity, same, only in place of speed you have to put velocity. So it is now uniform velocity, variable velocity, average velocity, instantaneous velocity. Go one by one, because velocity term is here, so we will write equal displacement in equal time. When body covers equal displacement in equal time, then it is uniform velocity. Variable, if speed changes with time, or you can say direction changes with time, then it is called variable velocity. Average velocity, total displacement divided by total time, because average speed is total distance upon time, so average displacement is total displacement upon total time. Instantaneous velocity, in the same way, it is also dx by dt, but here this x, that is position, is not distance, it is displacement. That is why here vector sign, I put here vector sign, dx by dt, but this is vector sign. If any physical quantity is vector, so vector symbol is arrow sign. You will study in my next chapter. This is the vector sign, in which this is known as tip and this is known as tail. Arrow is the symbol of vector sign. So this is instantaneous velocity. So today I told you about some basic concept of mechanics, like what is mechanics, types of mechanics, that other sub branches of mechanics, as well as motion, types of motion, elements of motion. In elements of motion, I told you about the different types of speed, different types of velocity, as well as I told you distance, displacement, speed, velocity and acceleration. Okay, all the best. God bless you.